Welcome. We're going to talk about design of a centrifugal compressor in this Ozone engineering vlog. As we've talked about it before, Ansys provides a set of tools called TurboSystem, which helps the engineers design and analyze any turbomachinery component. Let's start our project by dragging a Vista CCD module, which is for a centrifugal compressor, and then double click on blade design. Here we're going to essentially specify our duty point or best efficiency point. So let's have an overall pressure ratio of 2, keep the mass flow rate the same, maybe at 40,000 RPM. It's going to use air as the working fluid, and we're going to use the Casey Robinson correlations. We're not going to make any more changes in this tab. Next tab is gas properties. Like I mentioned, it's going to be ideal gas and air. And we move on to geometry. Let's make our hub diameter 32 millimeters and reduce our vane count to 6, and we're going to have splitter blades or intervanes of the same count. We also would like to have a tip clearance at the shroud of 0.5 millimeter. So once we define the operating point, the air properties or the fluid properties, and then the basics of the geometry, we're going to hit calculate. This is going to come up with a basic design, and it's also going to calculate us key performance numbers. And here, again, we can check our inputs: 40,000 RPM, total pressure ratio, and then we can see our efficiency over 80%. And to further check that, we can do an efficiency plot, and our point is over here with the square, and it is close to the curve, so it seems like this is a feasible design, and we can move on to the next stage, where we can quickly do a performance map using the function. And here this is a quick calculator which will give us what happens at off design conditions. For example, let's look at 5 different speeds, and let's do 10,000 to 50,000 RPM. And if we do a calculate, it's going to provide us with our pressure ratio versus mass flow, and the blue curve is our design curve at 40,000 RPM. We can change, look at pressure and inlet temperature impacts as well using this tool.